Hello and welcome. So we have a circle defined by a central angle of 100 degrees, and the area of the sector given to us is 160 pi over 9. And then we have a diagram to show that, and it's asking us what's the radius of the circle, meaning radius is center to outside. It's looking for what is that length there. Okay, so we're looking for what is the radius. Given that we know that the angle between two radii is 100 degrees and that this blue shaded portion here is the 160 pi over 9. Well, first off, let's find a way to relate all of these together. All right, so first I'm looking at is area of the shaded sector. Now, an area of a circle is going to be pi r squared. All right, that is the formula for the area of a circle. Now, we don't have the entire circle, right? Only a portion of the circle has been shaded in, meaning that we're taking a percentage of the area. We don't have all of it, but we have a part of it. So what's going to happen is that we're of this area, right? Of the area of my circle, how much of it do I have? Well, that's where your 100 degrees comes in. You know that you have 100 degrees out of all of the circle. Well, we know that the circle is 360 degrees. If you were to do a rotation from one point, go all the way around and end at the same point, that is a rotation of 360 degrees, meaning you have 100 of the 360 degrees. So that is how you can find the percentage of your circle. You have 100 of 360, right? And that's going to equal, right? That's going to give you the 160 pi over 9. Whatever the area of the whole thing is, times that percentage is the section, the blue shaded portion we have. So how this is going to be written out is that now we know that the area of our shaded section is going to be 160 pi over 9 equals the area of the sector equals the area of the circle, pi r squared, times the percentage of the circle that we have, 100 over 360. There you go. Now you have a relationship. Now you know how to relate your 160 pi over 9 to your 100 to your radius. All right, so now we just need to solve for our r there, right? Our goal is r equals, we want to find what the radius is, so now we just need to solve for it. So to do that, let's get r by itself. So the first thing I'm going to do is I'm going to undo that fraction. We have 100 divided by 360. So division of 360 can be undone with multiplication of 360. What you do to one side, do to the other. All right, so then I'm going to do 360 times my 160 divided by 9. So I'm going to do that in my calculator real quick. Divide 9, and we get 6,400 pi. Right? The 9 and the 360, 9 goes into 360, right? It divides evenly, which is why our fraction's gone now. So we have pi r squared times 100. Now keep in mind that the operation that's left here is that you have multiplication between the 100 and the pi to your r squared. Now, your goal is to get r alone so you can undo multiplication with division. Now, what you divide by is, I would move both the 100 and the pi at the same time, right? You're dividing by 100 because you're multiplying by 100. You're dividing by pi because you're multiplying by pi. Do both at once, save yourself the issue there, right? And what you do to one side, you do to the other. So on the right, all of that cancels out and you're left with r squared. Okay, now on the left, we have a lot of simplification going. First off, pi divided by pi is 1. That simplifies completely. And then we have 6,400 divided by 100, right? Essentially, those zeros are going to cancel right out and leave you with 64. So we have r squared equals 64. You're still solving for r. Last question, how do you undo the square? Square root, right? Technically, remember, you have a plus or minus when you take a square root, right? But keep in mind, we're talking about a radius, a length on the circle. Can a length be negative? No. So when we say that r squared of r squared equals 64, that's really just r equals 8 because we can get negative 8 coming back, and there's our answer. And there you go. Thanks for watching.